Okay, the quiz today for quadratic equations. And just today, I did write down the quadratic formula. But that's something you particularly need to know by doing a bunch of problems and using it. So that you remember it for the exam. Okay, so the first equation was x squared plus 7x plus 10 equals 0. Now, it turns out you can solve this by factor. Okay. If you just go to the quadratic equation, it's okay, unless I ask you to solve by factor. If I just say solve it, use whatever method works. But this factors into x plus 2, x plus 10 equals 0, which splits that into two equations. X plus 2 equals 0, x plus 10 equals 0. Because again, if x plus 2 is 0, this side is true because 0 times this will be 0. And if this one's 0, that makes the whole thing 0. So that's why we get two equations. We get x equals -2 and x equals -10. So the solution to the equation x equals -2 is a solution, or x equals -10. Okay. Can't be both. You can't say x equals -2 and x equals -10. That's logically ridiculous. X can't be -2 if it's -10. Can't be -10 if it's -2. Think about that logic. Okay. So, or by the quadratic formula. We use the quadratic formula to identify A, B, and C, and we get -7 plus or minus the square root of 7 squared minus 4 times 1 times 10, all divided by 2 times 1. So that equals -7 plus or minus the square root of 9 over 2, which equals -7 plus or minus 3 over 2. Okay. So the solutions are this is a solution and this is a solution. We say our solution to the equation is this or this. Both of these are solutions, but only one at a time. And this reduces to -2 or -10. Uh-oh. And it isn't 10. I factored carelessly. It's -5. I didn't check my factor, did I? Well, I caught 10 and I wrote down 10, but obviously 2 times 10 is not equal to 10, right? You gotta have, these numbers have to multiply out to this number. And we could say the solution set is the set -2, -5. Okay, well, that's straightforward enough. Second equation, we're not even going to try to factor it, although if you see something that allows you to factor it, it's a good idea to do that. Verify your solution, validate it. You get x equals -2, negative of -5 plus or minus the square root of -5 squared minus 4 times 2 times -9 over 2 times 2. Now I have written out the step, or say A equals this, B equals this, C equals this, but we want to continue to do that, probably for the rest of this course. Okay. just get in the habit of doing that to remind yourself what you're doing. But everybody was substituting correctly and identifying A, B, and C correctly. So I'm going to kind of skip that step. Anyhow, this comes out to 5, negative 5 is 5. And that's going to be 25. I'll go ahead and write out the details here. 25 plus 4 times 2 is 8, times 9 is 72. 8 denominator is going to be 4. Okay. Again, this is plus 72 because you've got the negative of a negative. Be careful about that. That's a common pitfall. Anytime you've got a lot of negative signs, you got to be real careful to keep it straight. Okay. Anyhow, the rest of this is very simple. You got 5 plus or minus the square root of 97 over 4. Now that could be written 5/4 plus or minus the square root of 97 over 4. So your solution set you just write out the solution for the plus, the solution for the minus. Now we're going to correlate this with the graphs. Okay. We're going to learn how to graph a quadratic function. You okay?
Yeah, measures.
Okay. So that's really it when you have a quadratic equation, except that there are a few little details. You can't simplify the square root of 97 over 4. But I think we're going to run into one here that you can simplify. So let's see how that could work out. Okay, we have x squared plus 2x plus 6 equals 0. Well, we use the quadratic formula. We get x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 6. All that divided by 2 times 1. And the numbers work out very simply. We get negative 2 plus or minus the square root of negative 20 over 2. Now, the square root of negative 20, try to do that in your calculator, it's going to yell at you. Yeah, if you got a properly designed calculator, it'll just blow up. Well, no, but it won't give you an answer. Now, some calculators might, but so I'm going to address this. Okay. So we're going to do a little factoring on that square root of 20. First of all, 20 is 4 times 5, so we'd write it as square root of 4 times square root of 5, right? And then times the square root of negative 1. I just break this thing into factors, one of which will be negative 1. If you got a negative here, then negative 1 is going to be a factor, okay? So if I multiply 4 times 5 times negative 1, I am going to get negative 20, okay? And the square root works like this, okay? You multiply several square roots, you can just multiply what's inside of every one, put it under one square root. Okay. And this is done over 2. Now, the reason I have a square root of 4 here is because square root of 4 is 2. Okay, it's a perfect square. So what I've done is I factored out a perfect square. And while I was at it, I factored out a negative 1. Okay, so the square root of 4 is just 2. And that's times the square root of 5. And the square root of negative 1 is I. That's something everybody should have seen. at some point, but a lot of people are a little shocked by it. That's not, we just say, okay, square root of -1 is I. Stands for imaginary. It's not a real number. However, when you get into quantum physics, you get pretty deeply into quantum physics, way deeper than past undergraduate physics major type stuff. You find that these square roots of negative numbers are necessary. Okay, we've known for a long time that they're convenient. For 150 years, those things have been convenient for solving problems in engineering and physics, and they've been used widely by professionals. Okay, so these I's are really important. Okay, matter of fact, I spent 2 years in graduate school laying the foundation to work toward a PhD in the theory of functions that have I's in them. Okay, it's a hugely highly developed branch of mathematics, and it's a kind of a difficult one. Okay, I ended up not spending the next 5 years jumping through the hoops for the PhD, partly because I didn't know if I could jump that high. Okay, it's a pretty stiff it's a pretty stiff row to hoe to mix my metaphors. Okay, so that's aside the point. I'm just telling you these things are really important. But right now, you just take square root of -1 is equal to I. Okay, we'll do more with that in pre-calculus. Okay, so then you could say, well, this is -2 over 2 plus or minus 2 square root of 5 pi over 2. And of course, you can simplify this. -2 over 2 is -1. Probably heard that. Well, obviously. Okay, so that's -1. And then this 2 will divide this 2, leaving you square root of 5 pi. Okay, so it's worth seeing that. Your solution set would then be this with a plus and this with a minus. I don't really have room to write it out, but I'll do that anyway. That would be able to do very deeply. Then I think you can see what I would write. Okay. So, two things you can do when you get this point is you do try to factor out a square, biggest square you can. Okay. Factor out the biggest square you can. It'll be square root of that, and you'll be able to get that square root. Okay. And then whatever's left, leave it under the radical. If you have a negative here, for the purposes of this course, you can stop and say, there's no real solution. And that's going to have implications for the graph of this equation. Okay, and we're going to see the graph. I'm going to show you how to graph these things in just a couple of minutes. All right, now, let's take the last one. Okay, now you remember the way the quadratic formula is stated. It says if ax squared plus bx plus c equals 0, then x equals negative b plus or minus square root of b squared minus 4ac all divided by 2a. That's the quadratic formula. Now, do we have ax squared plus bx plus c equals 0 in this equation? No. Okay, so if you just say that, okay, a is 1, b is 2, and c is 6, you're not solving this equation. Okay. You have to put this equation into this form. Well, that's pretty easy to do. We got x squared equals 2x plus 6. We want to get a negative, we want to get a 0 on this side. How do we do that? Well, we can subtract the quantity 2x plus 6. And over here, we can subtract the quantity 2x plus 6. That's perfectly legitimate. The equation that we get is going to be totally equivalent to this equation. We're just going to have a 0 over here. Okay, so that's going to give us x squared minus 2x minus 6 equals 0. Now, if you just write minus 2x plus 6 over here without the parentheses, you might end up with a plus 6 over there. Okay? And that is not correct. So make sure you do this step carefully because everybody knows how to do that. Just make sure you do it. Don't shortcut it. Don't write it out carelessly because it's very easy to do that. All right. Now, at this point, you go to the quadratic formula. Negative of -2 plus or minus the square root of -2 squared minus 4 times 1 times -6. All that divided by 2 times 1. And of course, everybody's fine with this as long as you're careful about the signs. The signs, if you're a little bit careless, you're trying to work too fast, you can end up making a unfortunate error. You'll probably see me make one before I'm done today. Just to pretend I'm making a mistake and show you that there's no great shame in making a mistake, but you got to check it. You got to try to avoid it. Okay. So anyhow, that's going to give us 2 plus or minus the square root of 28 over 2, which is 2 plus or minus the square root of 4 times the square root of 7 over 2. Why did I take out the 4? Because it's a perfect square. Okay. And there's no bigger perfect square. 7's a prime number. You can't take anything out. You can't factor anything out of 7. Okay, so that is 2 plus or minus 2 square root of 7 over 2, which equals 2 over 2 plus or minus 2 square root of 7 over 2, which equals 1 plus or minus square root of 7. Okay, so your solution set one plus the square root of 7. Put that over 6. And 1 minus the square root of 7. Okay, everybody understand that? Just be careful. Everybody knows how to plug into the quadratic formula. Everybody knows how to identify A, B, and C. Not everybody failed to be tripped up by this. Okay. But that's easy to fix. Just make sure you got equal to 0 on the other side before you use that quadratic formula. And get your signs right. Okay. And then you run through the homework set. At the speed I saw some people working in 30 minutes or less. Okay. And you need that reinforcement. If it takes you longer to work it out, that's fine. If you're very careful, very meticulous. It's worth the time. Okay. Make sure you do that because you're guaranteed to have a quadratic equation somewhere on the exam. Okay. Probably a couple of them because it'll lurk in places you would not expect. Okay. Now, I'm going to talk about how to graph the equation of a quadratic function. Now, you know how to graph linear functions. Using the intercept, using slope intercept, using whatever. And if you don't know how to do that right now, it's because you've forgotten it, but you knew it pretty well not too long ago. So you're going to have to review that. And we're going to do review, but the rest of the course is going to be heavily weighted toward review. Okay. Now, let's just take this last equation. Okay. We'll put it into the form where can equal 0. Okay. Now, can you tell me what the y-intercept of that equation is? We don't want to put this on a graph. So I'm going to put a graph down here. And we'll talk about this for a second. Okay, I asked to find the y-intercept, and so I said, well, look, mx plus b. That's not a natural thing to say at this point, okay? Nothing wrong with that. That's a common misconception. Even on final exams in pre-calculus, I'll have people try to apply mx plus b to a quadratic function, okay? Meaning that they don't recognize a quadratic function for what it is. So first thing we want to make sure is we recognize this as a quadratic function because that's a quadratic expression. It's an ax squared plus bx plus c, right? Okay. That's a quadratic expression. Now there's a linear expression in there, 2x minus 6, or minus 2x minus 6. That's an mx plus b expression, but mx plus b isn't helpful because that x squared is sitting there staring you in the face. So first thing we have to recognize this as a quadratic function. And we do want to talk a little bit about functions, and we'll be talking about that next week, and then the last class. We have 3 more classes after this one. So in addition to review, we're going to get your feet wet with functions, which we're starting to do right now. So I'm not going to talk about what a function is yet, but let's get a graph of a quadratic function. And then we're going to talk about what a function is. Okay, at this point, we could talk then about linear and quadratic functions. They have graphs, so forth. Okay, so first of all, recognize this as a quadratic function because of the x squared. Okay, now that we've done that, what's the x-intercept? What's the y-intercept? Under what conditions do you get the y-intercept? Well, where's the y-intercept occur? So let's. Okay, so I got a good answer there. The y-intercept occurs when x equals 0. And I said, exaggerated, and I said, something you got to remember all your life. 150 years from now on your deathbed, the last thing you remember. Well, no, that's not going to be. Okay, a lot more important things to remember at that point. But when the y-intercept, well, the y-intercept, yeah, it's something you want to remember as long as you're using any mathematics, looking at any graphs, or in danger of having to do so. Okay? Y-intercept occurs when x equals 0. Believe me, Remembering this will save you a lot of pain when you take recalculus. It's a fundamental thing, a fundamental property of the graph of any function, okay? So, okay, if x equals 0, what do you find out? Plug in x equals 0, what do you get? Okay, now most of you are sweating profusely because that was a terrible effort. Okay, no, it wasn't. That was easy, right? If you plug in x equals 0, you're going to get -6. I'm going to write that out in a little different form. I'm going to write y equals f of x equals x squared minus 2x minus 6. Okay, this does not mean f multiplied by x. Okay, this is what we call function notation. We'll talk a little bit more about it, but this is a good opportunity to give you just a taste of it, okay? And you're going to get more than a taste of it in the next couple of classes, okay? If x equals 0, first of all, replace this x by 0, and then replace all these x's by 0, right? Any mystery to that, except why in the world would I write an f of x or an f of 0? You'll see why. Just mechanically, without having any connotation on this. If I replace x by 0 here, and replace it here, I get this. And y equals f of 0 equals -6. Well, can you put that point on your graph? Swap down a point, label it, scale it, call it x equals -6, and doggone it anyway. All the beautiful handwriting I'm doing. Stupid camera blurted out. I think it was recognizable. Got to make a technology request this year for something instruction related. I just simply requested a 32-inch monitor that I could mount down there where that monitor is. It doesn't work. So I can see from here, 10 feet away, whether the camera's in focus. Okay, because this is a great camera. If they thought to include a manual focus, that would have been nice. Okay. That camera needs to be more or less permanently focused here. All right, anyhow, that's aside. Apologize for the blurriness and hope that didn't go too far, but just in case if it was blurry over here, there it is. And if it was blurry, even when I was doing this, there it is. Okay. Okay, so anyhow, I've asked you to, plot the point. X equals 0 because that's why we replaced x by 0, and y equals -6. Well, that point is going to be down here on the y-axis. Okay, so let's just say y equals -6 is here. Now that might not have been the best choice, but why that low? Because I don't have much room below it, so I'm taking a risk. Okay, I kind of think I'm going to get away with it, but I can't be sure. All right. Okay. So here's your y-intercept. That's going to be a point on the graph. Okay. Now, what are the x-intercepts? Well, what's the condition for an x-intercept? Okay. So for the x-intercept, Well, we already wrote it down, but we really want to be sure we understand this. You know, y is 0 on the x-axis. Y is -6 down here, +6 up here. It's 0 here. X-intercept. Okay, well, if we take this equation and replace y with 0, what do we get? Write it out for me, please. All right, now I actually have people do that solution. But of course, we already did that solution. I didn't see anybody copying down the solution. I saw people actually working it through. Some people made a couple of little glitches, but did it very quickly and very well, and did all the right steps with just little glitches with the arithmetic, okay? So you gotta make sure you don't get those glitches in your arithmetic. When you do the open math assignment, it'll tell you if you're wrong. And then you get to go back and check your arithmetic, and if you're wrong, it's almost certainly because you were careless with the arithmetic, and you'll learn to correct the arithmetic, okay? And it won't take you long, because everybody's got the procedure down all the way to factoring out step 4 in this case, okay? So everybody's in good shape with this. Just discipline yourself to do those problems and fix them if they're wrong, and learn what kind of mistakes you tend to make, okay? Okay, so x-intercept y equals 0, so quadratic equation, and if you want to solve the quadratic equation, well, if most people didn't remember all the details of this, although I think in some cases, if all the numbers were working out, it started to become familiar, okay? But everybody knows how to work this out. So I'm not going to do it again. I ask you to do it just to reinforce what we'd already done. Okay, so you get x equals then x equals 1 plus or minus the square root of 7. Right? Okay. So that means if x equals this or x equals this, we have y equals 0. Now I'll say the approximate solution set, which you could get from your calculator. Okay, square root of 7 is between 2.6 and 2.7. About 2.66 or 2.67. I'm going to go with 6.7, and I'm going to get them 3.67, negative 1.67. Okay, now you can check your calculator. I could be totally screwed up by that, but I'm pretty sure 27 squared is 729. And 1.6 squared, it's not 729. 2.7 squared. Okay, and 2.6 squared is like 656 or something like that. Okay, I want to think that hard right now. Anyhow, those are numbers we'll use for the approximation. So can you put those results on your graph? What does this tell you about your graph? Okay, now some people just can't help but mark off a bunch of points on here and say one's this big and two's that big, and so forth. That's okay. That's okay. But if you want to get a reasonable shape to the graph, you don't set the scale before you mark these points. Okay. Now, the smaller of the two numbers is the negative 1.67, the number with the least absolute value. And I don't want that to be too close to the origin. So I'm going to put it about here. This number is going to be a little more than twice this number. This is going to be twice as far from the y-axis as this number. So what I mean by that is, I'm going to say here, I'm going to say y equals negative 1.67 here. Fair enough? And then I'm going to say y equals 3.67. Well, if I double 1.67, I get 3.34, which is a little less than 3.67. So we've got to go about twice that far from the y-axis. And then a little more. Or maybe this will work. So there's y equals 3.67. Okay. And I use these dotted lines instead of trying to label the axis because the graph is going to go through the axis. It's probably going to go through one of my labels. Okay. They have a way of doing that when I label the axis. But this, I think, is a clear way to label it. And you understand that once I've said that here's negative 1.67, here's 3.67, then you pretty much know where 1 is and where 2 is and where 3 is. So you can line off the rest of your graph. You can even make points in the x-axis. Okay, and that's not a bad thing to do, but it's not necessary. We declare here's where y equals negative 6. Now all the other y's have to follow that scale. We declare here is negative 1.67. X equals negative 1.67, not y equals negative 1.67. So everything else has to follow that scale. In particular, 3.67 has to be a little more than twice as far from the y-axis as this. Now, having done that, I'll give it away. Obviously, you can't draw a straight line through all these points. It's not going to be a linear graph. Well, it's going to be a parabola. And parabolas have shapes like this. Okay. Furthermore, each parabola has an axis of symmetry. What's on this side is a mirror image through this dotted line of what's on this side. Now, mine got a little lopsided, so it doesn't work out that way. But if you draw a good parabola, it's going to have an approximate symmetry. That makes sense? Just like a U, but a parabola isn't a U. A U gets too steep too fast. Okay. And you learn that as you grasp the parabolas. But it's kind of U-shaped. And U kind of splits down the middle. Each half is congruent with the other half. Okay, well, if that's going to be the case, where's the axis of symmetry? Okay, so everybody did extremely well with this. Okay, after that little description of an axis of symmetry, it goes right down the middle. Well, it's going to go right down the middle of the graph. It's going to be right down the middle of these 2 points, isn't it? Because these 2 points are on the graph. The axis of symmetry is going to have to be like about here, which is as far from this point as it is from this point, right? So if I just do this, take my fingers, move them at the same speed, I find that my axis of symmetry ought to be about here. Now, all I did was I just kind of went like this, kind of move my fingers at the same speed. There's my axis of symmetry. Now I don't like my finger. Okay, I can even calculate the axis of symmetry. If I add this to this, I get 2, right? Because 3.67 added to negative 1.67, you subtract 1.67 from 3.67, you get 2. Okay. If I want to get the number halfway between, I add them together and divide by 2. That's how you do an average. So if I add these numbers together and divide by 2, what do I get? Go ahead and do that for me real quick. Okay, now that was really easy. Everybody got 1. And then I wrote it down here, so you can recognize what you got. So the axis of symmetry is halfway between the zeros. I add 3.67 and negative 1.67, I get 2. If I add these two numbers and divide by 2, I get the number halfway between. So the axis of symmetry is x equals 1. Okay, well, let me ask you another quick question. What do you get if you average these two numbers? Well, we're running real short on time and I want to finish some stuff up. But I'm going to say, or if we want to do it exactly, 1 plus the square root of 7 plus 1 minus the square root of 7 over 2 equals 2 plus the square root of 7 minus the square root of 7 over 2 equals 2 over 2 equals 1. Okay? Now, there's an important connection here. You have the quadratic formula, right? Where did this 1 come from? Well, in the formula, the 1 came from 2 divided by 2 right here. Okay? What's that? That's negative b over 2a. The axis of symmetry is always negative b over 2a. And that worked out. It worked out beautifully. At this point, there's more that I could say, but we're running real short on time. We're going to draw a curve that looks like this or this. Which shape to go through these 3 points? This one or this one? Okay, see if you can draw that shape between these points, symmetric about this axis. Okay, now if you want to get an accurate picture, people tend to want to use this as the low point. But this can't be the low point because if it was, there'd have to be another low point on the other side of the axis of symmetry, because that's what symmetry means. Okay? So if this is the low point of the graph, then this has to be the low point of the graph. The graph can't have two low points. Okay? So what has to happen is the low point has to be on the axis of symmetry. So we come down here, we level off, and then we come back up here. Now, it's a very important point here. It's the vertex. Can you give me the coordinates of the vertex? Or tell me how to get the coordinates of the vertex? X equals 1. So using the F notation that I've used over here, I'll say Y equals F of 1. And if I write F of 1, since F of X equals this, then I have to make all the x's 1. That makes sense? That's important. That's the foundation of function notation, which we'll be talking about a little more next time. You all are doing so well, I decided we'd go ahead and introduce it here. So what we get is -7. So the vertex is not at -6. The low point is not at -6 because that would totally violate symmetry. The vertex is at 1, -7. And the point you need to remember is, once you know your axis is symmetry, which is right there smiling at you when you work out the quadratic formula, okay? Once you get the axis of symmetry, you know that's where the vertex is going to be. So you just plug that x coordinate into your function and you have that very important low point of the graph, or the high point if the graph happens to be upside down. If x squared had a negative in front of it, it would be upside down. Very good. Y'all did great today.